Question 6. Triangle P is reflected in the line y equals x. So the line y equals x, remember, is a diagonal that goes through 45 degrees, yeah? But you just need to make sure that it goes through that point there. So when x is 2, y is also 2. When x is 4, y will also be 4. So it goes through those points there. So we need to make sure that's the case down here as well. So be careful to line your ruler properly so that it is appropriate. So that's line y equals x. Now when I reflect triangle P in y equals x, okay, because the line is diagonal, it's better to actually turn your worksheet around like that, and then when we reflect, this is our mirror line, we can actually see how far away we are from the mirror line. So that distance there is like one diagonal, isn't it? Okay, so we've got to think about in terms of diagonals, because in a sense y equals x is a diagonal line, isn't it? So you go across one diagonal, so we're going to go this way a diagonal. Okay, now that corner point is actually on the line, so that's brilliant. So it doesn't actually need to go anymore because it's touching the line, so its reflection will also touch the line. And this corner point, it is 1, 2, 3 diagonals. So you're going to reflect on the other side 1, 2, 3 diagonals. So it's going to go there. Okay, so my reflected shape, my reflected image, and they've asked me to call it Q. Okay, is like this. Okay, fantastic. And then it says triangle Q is reflected in the line y equals minus x. So remember y equals minus x is the diagonal but going the other way in the negative sort of direction. So when x is a negative value, that's what it'll be, a positive y value, and vice versa. We just need to make sure we line this up properly. So that will be y equals minus x. So I'm going to reflect Q over here somewhere. So again, we just need to be really careful here, so because it's quite far away. So just each corner point, just count the diagonals. So as I said, it might be better to sort of have it facing that way. So you could see now that from that corner point is 1, 2, 3 diagonals. So it's going to go back 1, 2, 3 diagonals. So it's going to be there. That corner point, 1, 2, 3, 4 diagonals, so it'll be 1, 2, 3, 4 diagonals, it's going to be there. And then this corner point, 1, 2, 3, 4, 5 diagonals, so it'll be 1, 2, 3, 4, 5 diagonals this way, so it'll be there. We need to label that shape then R. Then it says, describe a single transformation that maps triangle P to triangle R. P to R. So it's just like one we saw earlier, whereby you can see this has been rotated, I believe. So we could rotate that. And when we do a rotation, we need to see where the center is. Now, I'm looking at this and I'm thinking the center is probably the origin. It kind of looks like it should be in the middle there. But remember, what you can do is join the corresponding sides, corners, and they should intersect then, and they are, look, if you're doing it like without actually drawing it here, they are actually all going through the origin here. So I believe the origin there is the center of rotation. So let's just check that. So we'll put a little axis here, we'll trace the shape. So we'll turn that 90 degrees. We'll turn it another 90 degrees, and you can see then it lies perfectly on there. So again, we're going to say a rotation of 180 degrees about the origin, okay, or about 0, 0.